Timed PN. In the Petri-Net literature, three basic ways of representing time in Petri nets are used: firing durations, FD, holding durations, HD, and enabling durations, ED. When using FD principle, the transition firing has duration. In contrast, when using HD principle, a firing has no duration, but a created token is considered unavailable for the time assigned to transition that created the token, which has the same effect. With ED principle, the firing of the transitions has no duration, while the time delays are represented by forcing transitions that are unable to stay so for a specified period of time before they can fire. This is a more general concept since it allows for modeling of task interruption. Some authors use an even more general concept, which assigns delays to individual arcs, either inputs or outputs of a transition. When modeling several performance optimization problems, for example scheduling problems, such a general framework is not needed. It is natural to use HD when modeling most scheduling processes, as operations are considered non-preemptive. The timed version of CPN is defined by uses a HD equivalent principle, where the unavailability of the tokens is defined implicitly through the corresponding timestamps. While CPNs allow the assignment of delays both to transition and to output arcs, we further simplify this by allowing time delay inscriptions to transitions only. This is sufficient for the type of examples investigated here, and can be generalized if necessary. To include a time attribute of the marking tokens, which determines their availability and unavailability, the notation of timed CPN will be adopted. Tokens are accompanied with a timestamp, which is written next to the token number and separated from the number by @. For example, two tokens with timestamp 10 are denoted 2 @ 10. A collection of tokens with different timestamps is defined as a multiset, and written as a sum, union, of sets of timestamped tokens. For example, two tokens with timestamp 10 and three tokens with timestamp 12 are written as 2 @ 10 plus 3 @ 12. The timestamp of a token defines the time from which the token is available. Timestamps are elements of a time set TS, which is defined as a set of numeric values. In many software implementations the time values are integer, i.e., TS equals n, but will be here admitted to take any positive real value including 0, i.e., TS equals R0 plus. Timed markings are represented as collections of timestamps and are multisets over TS-TSMS. By using HD principle, the formal representation of a PT timed Petri net is defined as follows. TPN equals N, M0, is a timed Petri net system, where N equals P, T, pre, post, F, is a timed Petri net structure, P equals P1, P2, park. K greater than 0 is a finite set of places, T equals T1, T2, TL, L greater than 0 is a finite set of transitions. Pre, P times Tn is the input arc function. If there exists an arc with weight k connecting P to T, then pre-P, T equals K, otherwise pre-P, T equals 0. Post, P times Tn is the output arc function. If there exists an arc with weight k connecting T to P, then post P, T equals K, otherwise post P, T equals 0. FTTS is the function that assigns a non-negative deterministic time delay to every TT. MPTSMS is the timed marking, M0 is the initial marking of a timed Petri net. To determine the availability and unavailability of tokens, two functions on the set of markings are defined. The set of markings is denoted by M given a marking in model time, MP times M times TS, and defines the number of available tokens, and NP times M times TS in the number of unavailable tokens for each place of a TPN at a given time k. Note that model time also belongs to time set TS, KTS. Using the above definitions, addition and subtraction of timed markings, and the TPN firing rule can be defined. Given a marked TPN equals N, M, a transition T is time enabled at time k, denoted MT, keyboard, K if MP, M, K, less than or equal to pre-P, T, PT. An enabled transition can fire, and as a result removes tokens from input places and creates tokens in output places. The newly created tokens are accompanied by timestamps depending on the model time and the delay of transition that created the tokens. If marking M2 is reached from M1 by firing T at time k, this is denoted by M1T, keyboard, kn2. The set of markings of TPN reachable from M is denoted by or n, m,